All right, cool. I think we're going to go ahead and get started. Thank you so much, everyone, for coming. This is week 3 of our 5-week-long series this fall, covering a couple of really important tools for analytics, SQL and Python. For today's session, hopefully you know, we're going to be primarily focusing on Python. So we've been doing SQL the last 2 weeks. We're going to kind of put that on the back burner for today and next week, focus in on Python. And then in week 5 of this series, we'll kind of put them all together into a portfolio project. So if you're interested in that, I encourage you to come back for the rest of the series. I see a few familiar faces in here. Could I just get a quick show of hands if anyone's like first time in one of these workshops? Everybody been to at least one before? Well, welcome back. Thanks everyone for coming back. Great. Okay, so let's talk a little bit about what we're going to do today and next week. The purpose of this session is to get you a little bit familiar with a programming language called Python. Python is a pretty flexible programming language. What that means is you can use it to do a lot of things. We're going to use it to do some kind of data analysis tasks. You can use Python to do things like create entire websites, apps, all sorts of things. We're not going to do that. We're not going anywhere near that level of complexity. We're going to try to give you like a foundational understanding of what Python can do in the sort of data analytics realm. We're going to talk about how to figure out when you might want to use Python as opposed to one of the other tools in your toolbox like Excel or SQL. We're going to talk about how to look at, read, understand Python code, what it's doing, even if you're not the one necessarily writing all the code yourself. Maybe you're collaborating with someone, maybe you're using a generative AI tool. We're going to talk about how to kind of work with those, understand what's going on, make sure you know enough to sort of trust your results, know what it's doing in your analysis. We will talk about how to kind of write and edit code yourself as well. But just, you know, the way that the world is changing, that's not sort of the core focus. We're trying to give you a foundation that you know enough that you can sort of use the tools that you have. All right. We're also going to talk about sort of how to figure out what functions or functionality you might need out of your Python code and how to figure out when you need those things. All right, so it's going to be a lot of sort of how to think sort of critically, how to think in sort of a systematic way about what you're trying to do with your data, and then to give you the tools to do that, right? So like I said, we're not going to make a website, we're not building an application. This is not about sort of memorizing every bit of syntax of the code, but trying to get you to a place where you can kind of access some of the power of Python at a base level and give you a foundation that you can sort of build on as you're doing your own projects, hopefully going forward. All right. Okay, so we did this for the SQL session, so I would love to just get a feel for where we're at with Python. So if I could maybe just get like a fingers in the air, 1 to 5. 1 is you've never used Python before. 5 is you can write a bunch of Python yourself today before this session. Where are we at? Okay, awesome, cool. Some kind of 1 to 3 range. That's usually what we get in these sessions, so that is great. Either way, hopefully this will be helpful for you. Okay, cool. So we'll just do a little bit of setup here. In the meantime, I think just wanted to mention, I mentioned this in the SQL class as well. I'm here teaching this workshop because I use this tool, these tools in my professional work life every day. So trying to give you all as real of a taste as I can of sort of how this looks in the work world. I work at a podcast advertising tech startup, right? So kind of in this broader kind of advertising communications marketing space, doing data using tools like this. All right, so if you have any questions about tools, anything like that, happy to help answer that. We will be using Hex, which if you've been here for the last couple of sessions, is the same tool we've been using before. So if you've been here in the previous sessions, you can just go to app.hex.tech and just sign in with your USC login. If you haven't been to one of the sessions in this series yet, you're going to want to go to this link that's on the whiteboard here, Digital Lounge Analytics. .carge.co, 2 R's in car, no M on .com or .co. that will give you a sort of longer invite link. So the first time you ever log into Hex, you need to do that. All right, that link will take you to this page, which will get you this big, long invite link that you need to do the first time. All right, and then just make sure you're using your USC email. I think it'll let you do a Google or Microsoft login. Again, if you've already created a Hex account in the last couple of weeks, you can just go to the regular Hex login and do that. If you have not yet signed up, you're going to need to click on this link to just get activated into our account. All right. Hex is a tool that I like. I've used a lot of different sort of data analysis and business intelligence visualization tools. This is one I really, really like. It's super flexible. You can use SQL, you can use Python, you can also just sort of build charts with sort of a point and click interface as you would in many other tools. So should be quite familiar for you. All right. And as I mentioned, this tool, they've sort of they have like an education plan. So for taking this workshop, you should have access to this. I think it's for 6 or 12 months after this workshop is over. So you can use this tool for coursework or just your own continued learning if you like. All right. Hopefully you're all set up in there when we get started. If you have any issues actually getting into Hex, let me know. A little bit of sort of our last bit of logistics housekeeping here. Once you're in Hex, you should look for our fall 2025 week 3. Should be in somewhere on your home screen, or if you click projects on the left-hand side, you should see it there. The most important part is that you make your own copy. So you're going to hit the ... and then duplicate on our fall 2025 week 3 workbook. All right, this is going to be your own copy to type in your own code, get doing your own stuff today. So just make sure you make your own copy. All right, if you click on it yourself and you get to a screen that looks like this, that's all good. You can just hit the arrow in the top next to the title there and do duplicate. I'll do that as an example. Once I duplicate, I'll get something like this, and I can add my name at the top just so I know which one it is. Rachel's copy. Okay. Anyone have any issues finding that? Issues logging in? I think, yeah.
Oh, wait, maybe.
Projects on the left-hand side. And should, yeah, there you go.
Thank you.
Cool. Just make sure you make your own copy up there from the top. Right next to the title up here, you should be able to do a little arrow and duplicate. All right. Fabulous. Cool. All right. So before we get into the sort of getting to writing some Python, I'm going to start with a little bit of background. All right, so as I mentioned, Python is a programming language that can do a bunch of things. What we're going to use today, what is a very common use case for it, is called scripting. All right, scripting is when you're writing a little bit of code for a task, but you're not writing a whole application, a whole website, etc. It's quite powerful for data analysis. A lot of people use this in a lot of different industries. So software engineers, even if they don't normally use Python for their main job, will use little bits of Python to do little analytical tasks like this. Obviously, data scientists, data analyst type of roles will use this. It can also be used sort of across the board. This is one of the most kind of accessible, flexible programming languages that you can learn. We talked a lot about SQL the last couple weeks. SQL is very specific to kind of interacting with structured data, doing sort of all those mechanics that we've talked about, so grouping, summarizing, etc. Python can do all of that and more. So it's kind of like the next level up, sort of next, if you're thinking about your tools, a sort of like level of power of analysis you can do. You've got sort of Excel on the bottom, you've got SQL as sort of the next level up from that, and then Python is even the next level up from that. Much like SQL, Python is a language where knowing just a little bit puts you very far ahead of someone who knows none. All right, so you get a lot of value out of knowing just a little bit. So that's what we're hoping to get you to over this week and next week. Get you to a place where you kind of have enough to be dangerous. All right. I pulled a thing from the python.org website, which is that it's all about automating repetitive tasks. All right, even sort of the applications that are built in Python are sort of about this idea of how do you automate repetitive tasks, of which there are many in any sort of analytics. All right. So what does it actually look like to use Python for data analysis? We're mainly going to be interacting with data in something called a data frame. Okay, we're talking about data frames a lot. What is a data frame? It's a table of data. You can think of it as sort of very similar or interchangeable with a SQL table or an Excel spreadsheet. All right, if you need something to picture in your head, you can picture a spreadsheet. And with Python, we can do a lot of things, a lot of different types of interactions with our data frames. So we can create new data frames, we can import data from a variety of sources, we can export data to a data frame, we can add on to our data, edit our data, make transformations of our data, join and summarize our data frames, lots and lots of things we can do here. Some of this might sound familiar. This is all stuff that we can do in SQL. We can do all that same stuff in Python plus more, right? So what are sort of some more concrete things that we can do with Python scripts? So we're writing maybe a few lines of Python to get something done. As I said, anything you can write a SQL query for, you can write in Python. And you get access to a whole bunch more functions that can do other things. Things like cleaning and manipulating data, things like cleaning up your text, etc., are going to be much easier to do at scale in Python. You can also sort of transform your data as much as you want. You can think about any sort of mass kind of reformatting, calculations, those types of things are things that we can do in Python. You can define your own transformation and sort of reuse that. That's called a function. We'll talk about that a little bit at the end today, more next week. You can kind of extract data or extract certain data points. And then one of the most common reasons that I use Python, and I think a lot of people use Python in the real world, is to prepare your data to use in a tool like SQL or Excel. All right, so SQL and Excel are a little bit kind of easier, more approachable, more people know them. There are many, many times where you might want to do one or two of these kind of steps in Python to sort of prep your data, and then you can dump it into a spreadsheet and manipulate further from there. Right, so it's just one of these many tools in your toolbox that you can use. And in general, more broadly, whenever I pull out Python, it's usually because I'm at work thinking to myself, there's got to be a better way to do this repetitive thing. Okay. You could also think of it as if you are working on some sort of project in a spreadsheet. Maybe it's a spreadsheet that you have open that has so many rows of data that it's crashing your Excel, right? Or your Google Sheets is loading really slowly. That's a moment where you might want to pull out a tool like SQL or Python, right? So it just gives you sort of one more level of power. All right, Hex is the same tool that we've been using the last couple of weeks. Just as a quick refresher, it functions as a series of cells that link together. So far, the last couple of weeks, we've been using SQL cells, meaning whenever we're interacting with our Hex document, we've been coming in here to add a cell and we've been hitting SQL to type in more code. Today, we're going to be hitting Python, but the beauty of Hex is that you can switch back and forth, right? So as I mentioned, it's quite common to do a little bit of preparation in Python and then switch to SQL. You can do that very seamlessly in a tool like Hex, which is awesome. And then all of those cells, including the ones we'll write in Python today, they play very nicely with SQL and also with the built-in visualization stuff in Hex. We're also going to dabble a little bit in some more custom visualization, a little bit more powerful, again, which you can do with Python, right? Okay, so make sure you've got your week 3. You should have a copy. You should give it should say something like copy at the top. You can stick your name in the title just to make sure you have that. Once you have your copy, the next very important thing to do is to hit this run button in the upper right hand corner. It says run all. All right, once you do that, that's going to go ahead and load your data frames for you that I've sort of set up. It's also going to show this silly GIF I've put at the top. So make sure you have a copy and you've hit run. Anybody have any issues with that? We're all good with our own copies? Okay, perfect. All right, great. So a little bit more context specifically about what is going to look like when we start writing some Python. Okay. So a general thing to know is that anything that you write in Python can be wrapped in a print function, which will help you see the results. All right, Hex is going to often sort of do a preview for you without that. All right, but if you're feeling stuck, if you're not seeing what you want to see, you can type the word print, put whatever code in parentheses, and Hex will print it out for you. All right. A couple of other terms to know that I'll be throwing around a lot today. Data frame, again, this is sort of your Excel spreadsheet. This is sort of a structure we're going to be interacting with. It's got rows, it's got columns. A data frame is a type of object. There are a bunch of objects in Python, but data frame is really the main one we are going to be talking about, right? Function and library we'll talk about a little bit towards the end of this workshop today and more next week. But a function is going to be a series of steps that we can define in Python that we can apply to whatever inputs we want. So let's say we have a data set where we want to be doing the same sort of manipulation on every column. Instead of doing it on every column separately, we can define those steps in a function and just apply that function everywhere. All right, so the way to avoid sort of repeating work. And the other reason that Python is so powerful is it has a bunch of libraries. A library is a bunch of functions that somebody else already wrote. These are typically like open source type of things that you can just use. All right, you can just see if there's a library that does what you need to do and you can just use it as sort of a more like beginner casual user of Python. This is a great way to access some of the more powerful features, and we'll walk through an example of that today. Okay. So let's write a little bit of code. Okay. So you're going to go into your Hex project. Make sure you have hit the run button at the top. First thing you want to check is that your data tables already exist. To do that, you're going to go in your left-hand your left-hand sidebar to your data browser. That's your little lightning icon at the top. You're going to click data frames in here, and you should see a list of 8 different data frames populate: athletes data, medalist data, ratings data, etc. All right, you should see this list here. If you don't see this list, you probably didn't hit the run all button over there. All right, so make sure that you do that. You'll see in sort of the main section of your workbook that I've input a little bit of code here for you already. This code we are going to deconstruct next week, but this is a Python cell. What this code is doing is loading our data for us, in one case from a file that's just on the web, and in another case from an Excel file that's actually attached to this workspace. Okay, so I'll talk a little bit more about how this code specifically works next week, but that is some Python that's in here already. Okay. Same with these next two. They're just doing a little bit of admin for us, which I will talk about more later. There's already some code cells in here. You can add any more code cells. You can hover in between any existing cells, just between those boxes, hit the plus sign, and that will allow you to add. We're going to be adding Python cells pretty much exclusively today. Right? Cool. So once you're in a cell, you can start interacting with your data frames. One of the main ways that you might interact with a data frame is going to be to sort of take a look at it, see what's going on in there. Okay. One of the ways that you can do that in SQL, we were doing sort of selecting the first 10 or 20 rows of our data set to take a look. In Python, we have a function that looks a little different, but is doing the same thing. We can give it the name of our data frame dot head, open parentheses, close parentheses. A lot of what we're going to be writing today looks sort of like this. So the name of one of our data frames dot head, open parentheses, close parentheses. I'm going to run that. It's going to think for a moment. All right, great. And so once I've run this little bit of Python here, I'm going to get sort of a preview of my result. In this case, this is going to return to me my top 5 rows of whatever this data frame is. And I could take a look at what this data looks like. I can also check over here in my data browser view, if I click on one of my tables, I can see what my column names are, and I see those going across the top here in my little preview, and I get a sense of what my data is going to look like. All right, so this is the same as our select star from transcripts data limit 10 kind of thing that we were doing. All right, but this is returning the first couple rows of one of our data sets. All right, other kind of just basic accessing our data in our data frame, we can access any individual column of our data set using square brackets. All right, so let's say we want to take a look at a cell here. Much like SQL, you're going to want to sort of put one sort of code task per cell. That's going to, it'll get a little funky if you try to combine them, and you'll get this nice preview. So anytime I'm writing a new chunk of code, I'm just going to write a new cell. You can add as many cells as you want. Let's say I wanted to take a look at my ratings data. All right, so I can come in here. I'm going to type the name of my data frame, which is ratings data. It might give you a little pop-up sort of autocomplete, which is great. Go ahead and hit tab to use that. And then I'm going to use my square brackets, and that way I can access any of the columns in my data frame. I can double check what those columns are called on the left-hand side here in my data browser. All right, so if I wanted to take a look at, say, the air date of this data, I can do something like this. So I have my name of my data frame, square bracket. In my square bracket, in single quotes, I have the name of one of my columns. This is just me saying I want all the data from this data table that's in this particular column titled air date. All right, and then I can get a little preview of what is in that column. In this case, it's going to show me, all right, a few dates, 1989, 1990, etc. It's going to do a little dot, dot, dot in the middle just because this is a little preview, but it's got all 172 rows of my data here. Okay. That is how I access a column. That would work for any of your column titles, any of your data frames. Next thing we might want to access is a specific row of your data set. All right, so it's very similarly, we are going to be able to access any individual row, right? So any piece of information this way across our data frame as opposed to a column. To access a row of data, I'm going to come in here and add another cell as an example. I'm going to give it my data frame. I'm going to use .iloc, LOC for locate. All right, and then I can give from here a number of the row that I want to give. So let's say maybe what's in the 100th row of this data set, and this is going to give me a little preview. Yeah. An error with the ratings data. All right, first thing to double check is your spelling of your model, that you've got square bracket, single quote, and that your spelling of your column name matches your how it's spelled in the same place. Feeling good? All right, here I'll leave ILOC. Go ahead and do an ILOC. Pull up one of your rows. No dot in that one. Yep. Yep. So your ratings data, where you're grabbing your square brackets to go to your column, there's no period there. We're going to be using a period here when we're using, this is sort of like a method to go find this row. When we're using a method, we have a dot there. All right, so we can get to any column in our data set by just naming that column in our square brackets, and we can get to any row in our data set by using our .iloc square brackets and letting it know whichever number row we want to pull out of our data. All right. Great. Okay, we already talked about our data browser. As we continue through our session today, we'll be generating new data frames. As you do that, those will also be available in your browser. So you can keep this open or pop this open whenever you want and make sure your data frames are showing up as expected, the right number of rows, right columns, etc. etc. All right. Cool. So we're going to start interacting with some different Python data types. All right, there's a few different types of data that we are interacting with within our data frames. Okay, so just in general, any of the sort of basic information format types are going to exist in Python. So things like basic math, as you might use in Excel, is going to work in Python. All right, so anything like this will run and return a mathematical result, right? It'll evaluate any sort of numerical, mathematical, etc. Text, same thing. We can interact with strings or text in Python. A lot of our columns of data in these sample data sets include a lot of text data. We can manipulate that text. All right, so to think about individual pieces of text, for example, it's my little silly example. For example, we can add chunks of text together, stick them together like this, so that they can be combined. A more real world use case for this might be like first name, last name. You might want to combine, for example. Next thing to be aware of in Python is arrays or lists. All right, so you can create sort of conceptual lists of objects, which you can use with logic in Python. All right, so if you have a list or array of information, you can add to it, you can manipulate it, etc. And lists are typically denoted with those square brackets. So things like this. Let's see. This is a list containing two strings, two pieces of text, right? Each item is denoted with those single quotes, and there's a comma in between. Again, I can do a variety of different types of manipulation on these, including I could just add them together, for example, add bananas in here. All right, and that's going to return one list containing all of those items. All right, very simple examples, but just giving you a sense of what you can do as far as basic manipulation. Okay. Now, any of these pieces of manipulation that you can do on an individual sort of piece of data, so like a number or a string, we can do on a column or row of our data set, more typically a column for something like this. So I can grab any column, any numerical column, and perform whatever mathematical operation on it I would like. For example, in my ratings data, if I want my ratings to be on a scale of 1 to 100 instead of 1 to 10, I could just simply multiply everything in that column by 10 using just one line of code like this. All right, so let's take a look at what that looks like. Add a new cell here, pop into my ratings data set. I need to make sure that my column I'm going to do any math with is already a number. So in my little data browser here, I get a little bit of information about the format of my data. I'm looking for something that says int 64 or float 64. That's going to indicate either a decimal or a integer number, which means I can interact with it with mathematical operations. All right, which would allow me to do something like this. All right, all these scores without sort of this, if I'm not multiplying by 10, this column looks like 7.6, 7.7, etc. If I multiply by 10, maybe I just need to convert this for some reason. Now my scores are going to be 76, 77, etc. All right, so I'm starting to see how I could manipulate an individual column of my data set. Variety of ways. All right. Okay, so we've talked about a few kind of types of data, right? Strings or text, as you may think of it, numbers, any sort of numerical, integer, or decimal data. A list, which could contain strings, integers, etc. Anything could be within the list. And then data frames, right? Data frames is sort of that first piece that we talked about. So what we've been doing so far, just here is just typing in some stuff and printing it out. We're not saving it anywhere, right? So if I want to go back and access this array of information, these scores on a scale of 0 to 100. I haven't saved this anywhere, so I can't go back and interact with this later. So that is where variables come in. If you've done any sort of kind of like basic programming class, HTML, anything in any other language, variables might sound familiar. This is a common sort of concept in programming. Same idea as variables from math class. All right, you give something a name, you can store values in that name and then refer to them that way. Okay. So you can basically think of this as a post-it note, right? If I'm storing, especially as I'm starting to store maybe a bigger array of information, I could have my favorite snacks array be apples and Nutella. And then I could remember I forgot my third and most important favorite snack, gummy worms. All right, I can add that to my list. And then anytime I'm referring to favorite snacks, I'm getting whatever information is stored in there. All right, you can see that very simply in Python like this. I could give any sort of variable name as long as it's got no spaces. So typically in Python, you're going to use underscores, and an equal sign will let it know that you're going to assign a variable. I could do something like this. All right, give it some text or a list or something else like that. And then I could ask it to print out what is stored in that variable. Okay, and then it's going to print out whatever is stored in favorite number, which in this case is 24. Okay, so anytime you've got sort of a piece of text, again, no spaces and an equal sign, that's a variable name, and equal sign means you're assigning a value to it. It will overwrite whatever was saved most recently. So if I come down here, let's say I've got another code cell, I'm doing something else in my code, and I'm going to note here now that my favorite number is 37. When I run this cell, it's going to tell me that my favorite number is now 37, right? So variables can be updated anytime, and it'll always just pull your most current value. Okay, basic idea of variables, make sense? All right, great. So variables might seem a little basic. The reason that we're talking about them is sort of similarly to how you can create a variable, you can create a new column in any data frame that you're working with to save any results or calculations. Okay, so back to our example where we were changing the rating to be on a scale of 1 to 100 instead of 1 to 10. We want to multiply all our values by 10. That's sort of the transformation that we're doing. If we want to store that data, be able to access that information again later, we're going to need to save it to, in this case, our variable that we're saving it to is a new column in our data frame. All right, so if we go back to our thing here, I'll do a new cell. Let me go copy my piece from before. All right, so this is the same little chunk of code right here. I'm going to my ratings data frame using square brackets to get to my rating column, and then I'm doing a little mathematical manipulation. I'm multiplying by 10. If I want to save the results, I'm going to add an equal sign. All right, and then on the left-hand side of my equal sign, I'm going to come up with a new column name. So just the way that I'm referring to an existing column here, I'm going to sort of manifest a new column into existence with the same format right here. So I'm going to refer to my data frame. Make sure I spelled it right. Thank you, autocorrect. I'm going to put in my square brackets. I'm going to put in my single quotes. And now I'm going to come up with a column name that sounds good to me. So maybe I'll call this something like score out of 100, something like this. Again, typically you're going to want to use underscores. That's sort of like the Python format for not using labels with spaces. All right, so once I've done that, I hit run in my cell there, or you can do Command Enter on your keyboard. All right, and I will notice now something interesting has happened. It hasn't printed anything out for me yet, but before I take a look at that, I'm going to go to my ratings data frame in my data browser, and I'm going to see that there's now a 7th column available to me. So before I had these 6 columns, now there's a 7th one called score out of 100, and it's a number. Okay, it's a decimal number, which is cool because that means that this calculation that I did is now saved in that column. I can go access this column whenever I want in any other calculation or cell, just like this. Let's see, ratings, data, score out of 100, something like this. And now when I reference this column, it pulls up the result of the calculation that I did. Yeah.
It says error from you whenever I.
All right. Let's take a look. All right, we did our equal sign. Looks like it's got to be a capital R there. So here it says key error rating. It seems it's not recognizing the column name that you've got. So column name has got to match exactly how it's spelled and capitalized right here on our data browser. So in your square brackets there where it says rating, I can get a lowercase r. It's just got to be a uppercase r because that's how it is here. Most things in Python are case sensitive, so good thing to know. Other questions, errors? This one? Did that solve it? Sweet. Okay, cool. All right. Cool. So obviously this is like a very simple calculation. We didn't do any like groundbreaking data analysis here, but you can start to see how as we sort of add layers onto this, we can store new information to our data frames, which gets quite powerful as we go. All right, cool. So we did our column by 10. You can add another column that multiplies the ratings data by 100 by any number if you want. Any sort of mathematical manipulation or text manipulation we can do on those columns. Okay. So we've sort of been talking about how to sort of transform information. So when we've added our new column, we have new information in each row in that column. The other place that this gets powerful, much like SQL, is we can summarize our data. So essentially collapse the number of rows that we have down to some sort of summary information. All right, so you could think of all the common examples of this, maybe adding up a sum or a total, taking an average, etc. Those are the types of things that we can do here. So this is an example of how we could take what is, find out what the average rating is for this data set. All right. So we can come over here. Here, very good. I'm going to add a new Python cell. Go to my ratings data. In this case, I want to take the average of a specific column, right? I can't just take the average of my whole data frame because it also includes text data. There's not really a concept of an average of text, right? So I'm going to reference a specific column, same thing, my square brackets, my single quotes, make sure that spelling matches exactly. And then I'm going to add a sort of summary method on here. So I'm going to use my dot. All right, this is the same sort of format as that dot head method we were using earlier. But this is going to be the mean. It's taking the mathematical mean or the average of this column. So if I pop back to my data set here, adding my dot mean, ahead and run that, and it's going to give me my result, which is 8.38, et cetera. Makes sense. When I went and looked at my data before, right, I know that this column is normally 7.6, 7.7, etc. So this sort of passes the gut check. All right, now that's taking the mean of our entire column. We can also might not want the mean of our entire column, but we might want the mean for individual subgroups or a sum, etc. So for example, if we want to find out what the highest rated season is, we would need to group our ratings data by season. So for that, we can use a method called .groupBy. .groupBy works, you give it a list of one or more columns that you want to group your data by. So in this case, we're just going to go ahead and group it by one column, our season. So that will look something like this. I'm going to add another new cell here. Ratings data. All right, this is where we're going to add our dot group by. Like this, group by all one word. All right, and then within our parentheses, so we're gonna sort of be parentheses and our square brackets. The reason for that is that our square brackets here are denoting a list. Our list could include multiple things. All right, so here we are doing our regular parentheses, our square brackets, and in this case, season with a capital S. All right. And then what is the mean within those groups? So I'm just tacking on my dot mean, same as I had it on the end before, same thing here. All right, dot mean. And we'll take a gander. Okay, and now this is going to give me a little data table. So this is down to 9 rows when I know that my original ratings data set has 172 rows, right? This has 9 because I'm condensing down to my different unique season numbers. And it's going to give me my mean data here. So my mathematical average of any of my columns that are a sort of, I could take the mean of, meaning that they are an integer or decimal, et cetera, their number. All right, so for season 1, I can see my average rating, the average of my vote count, and the average of my score out of 100, which is that column I added before, right, where I'm just multiplying by 10. Pretty cool. All right. Okay, average number of vote counts. Yes, we did this already. Okay. So we can do a variety of things, right? I just did average as an initial example. We can do a bunch of other types of summarizing here, anything we would want to do with subgroups of our data. So dot mean gives us the average, dot size will give us the number of rows, all right? Dot count will give us the number of rows that aren't empty, all right? So if there's a row that's empty in that column, dot size will count it, but dot count will not. Also, once we've grouped our data, we can do some sort of manipulation with those groups. So what's the first row in that group? What's the last row in that group? Let's say we wanted the episode title of the first episode in each season. We could do something like dot first, dot last. Dot get group will do sort of a filter. So this would be similar to a where clause in our SQL statement. Get group, and then we'll give it whichever value we want to filter by. We'll filter our table down to just those rows. We can also get the number of rows and then further sort them. So these methods are with our kind of dot and then our method name can be sort of stacked together, right? So we could grab the total number of rows for each group, and then we could do dot sort values, another method to sort whether we wanted them ascending or descending, get the number of rows and sort them. All right, so lots of things we could do here, lots of different options for our methods for interacting with our data. There are many more, and these are just a few to get us started. Okay. All right. So, so far we've been kind of revisiting our ratings and transcripts data, which is the same Seinfeld data set that you all might have recognized from our previous sessions. I also have loaded in here a bunch of data from the 2024 Paris Olympics. So we will use that, which is these guys here. So hopefully you did your run all. So these data tables, data frames are already populating for you. But we'll see we have athletes, medalists, medals, rowing, teams, volleyball. There's obviously many more data sets in the Olympics data if you're interested, but these are some that we're going to start to play with. Okay. All right. So an example of a type of question we might want to answer, kind of basic analysis, how many medals did each country win? All right, which we would want to figure out from our medals data set. So we probably want to go through our kind of normal analysis process for this sort of question. Meaning we want to take a look at what does our data look like. So for our medals data, I'm going to take a look at my data browser here and take a look at what my column names are. All right, thinking. There we go. Okay. So here I've got the medal type, medal code, medal date, name, gender, discipline, event, Looks like I've got a bunch of other columns, country code, URL, etc. Always good to do sort of a gut check and know what column is which, what I want to be grouping by. So I would usually, before I answer any sort of question, grab the first few rows, take a look at it myself. So I would do metals data dot head like this, and just take a look at a few rows of my data. You might remember this from SQL last week. So metal type gold, silver, bronze, metal code 1, 2, 3. Got dates, names, genders, cycling, time trial, etc. All right, I can see, and I can scroll over to the right-hand side and see more information about each of these medalists. All right. So if this is what my data looks like, next thing I want to get to is summarizing by country, right? If I want to figure out how many medals did each country win, I'm going to want to do some summarizing. All right, in order to do that, I'm going to use my group by. So I'm going to come in here, do my medals data, and I'm going to use my dot group by. All right, again, once you start typing group or any of the method names, you might get a little autocomplete, which is cool. And then I need to give it a column name to group by. All right, so figure that out. I'm going to come back up to my data here and just take a look. It looks like there's a few different options. I could use country code. I could use country. I could use country long, which looks like it's largely the same, but maybe is different for some countries. I think I'm just going to use this regular old country column here. So I'm going to come down to my next code cell, and I'm going to put in the title of that column that I want to group by. In this case, it's just country, and I can double check here if it's capitalized or not. Looks like it's all lowercase, so I'm good there. And then instead of an average here, I don't want an average, I want a count or a size. So in my little notes in here somewhere. Up somewhere. Yeah. Okay, great. In my dot group by, I want to use my method to get my number of rows. So I'm going to use my dot size. All right, run that cell, or again, you can do Command Enter, and this will give me a little preview of my results. First thing to check is that my number of rows went down. So my number of rows now is 92, down from 1,044. So that's good. I've got 92 unique countries that have won a medal. And then I've got here each country and its count number of medals summarized from that table. It's going to do my little dot, dot, dot in the middle since this is just a preview, but I can get a sense. I can see the United States won several, etc. All right. Any questions about what this line of Python is doing? Making sense? Right. Cool. Okay. So this is a pretty simple question, ultimately answered with a pretty simple line of Python. Something else we could do is we could add on this sorting option if we wanted to, if we want to sort our number of rows or sort our rows by our values, right? We could do that as well. So lots of flexibility, lots of things we can add on. Okay, so pretty simple question, relatively simple chunk of code. Let's talk about a little bit more of a complicated question. Something that would be a little harder to answer in, say, Excel or SQL, to give you an sort of sense and example of when Python starts to be really valuable. So this is a question that we might have. What is the most commonly used word, or what are the most commonly used words in the episode titles of a TV show, especially a long running one? In this case, the data set we have is for the TV show Seinfeld, all right, all their episodes over time. That's a question that might be interesting. We might want to do some sentiment analysis on the text, figure out if there's buzzwords or certain words from certain generations or things that might appear in that data set, right? You can imagine lots of interesting reasons to look at that data. But this is a type of question that you could imagine we might ask about other pieces of data as well. So we might also want to know what are the most commonly used words in those episode descriptions, for example. That's another piece of sort of like text sentiment analysis we could do. You could ask this about any sort of text-based piece of data. So since we're asking this sort of similar question about different data points, this is a good use case for a function. All right, what a function would do in this case is sort of the core of our question. What are the most commonly used words in whatever column they're stored in? And our function can do the steps that are needed to go find those words, count them, put them in order, etc. All right, so we're going to talk a little bit, kind of talk through this example and try to put ourselves in the shoes of understanding how do you do the kind of structured thinking that you need to do to write these bits of code. What are the kind of questions you need to think through to do that? So this is sort of the little like checklist you want to go through. Figure out exactly what your question is. I'm going to give you that in this case. Figuring out exactly what your question is. What exactly is your desired output? What is your input? Specifically, what columns and what data frames do you need to input into your function to get your desired output? What is that very first piece of information you need to answer the question? How can you sort of validate or take your first step towards your result? And then the last question, is there an existing function that can help you get your desired output? This is this library idea that I was talking about earlier, right? So the purpose of learning a little bit of Python in a setting like this is not to memorize any specific function or method, but to understand what they can do such that you, with the assistance of Google or ChatGPT or whatever, can sort of look at some code, understand enough about what it's doing to get done what you need to do. Okay, so this is sort of the thought process, the sort of structured thinking that you want to go through. So we're going to go through this for our example. What are the most commonly used words in whatever set of text? All right. So how would we walk through this here? Our question, what are the most commonly used words in, we'll start with our Seinfeld episode titles data set. Okay. What is our desired output from this question? Like, what do we want to end up with? We want a list of words in order of most commonly used to least commonly used. All right. If this were the Friends data, you know, the one where, right, like those words would be the most common because they're in every episode title. Okay. What is our input? So what do we have to give? This is going to start from our data frames. All right. This is a great moment to look in your data browser and make sure you have the information, the data frame, and the columns that you might need. So in this case, I'm going to go to our transcripts data set and take a quick look at what columns of information I have available. This might also be a good moment to take a look at the head of my data, a few sample rows, and make sure I know, kind of give myself some intuition for what exactly all of these columns are. These are fairly straightforward, but always good to actually get some eyes on it. Looks like this sort of weird unnamed column is just a row number, just something weird about this data set. Then I've got my character name, my actual line of dialogue. So this here is an actual chunk of text. My episode number, my SEID, and my season. So as I'm looking here, I'm actually thinking, if I'm trying to answer my question, my most commonly used words in episode titles question, my transcripts data is actually not the right one to use, right? This data set actually doesn't have my episode titles. So this is why you want to kind of do this step. Make sure that you're thinking of the right table. All right, so in this case, my other data frame that I have here that's related to my Seinfeld data is that ratings data set. All right, so I think I did this earlier, but I'll just do it again real quick here. I'm just doing my ratings data dot head. All right, here I see season, title, air date, rating, etc. Description. This is going to have my episode title. All right, so when I'm thinking through, all right, what's my input to get the output that I want? My input is going to be this data frame, most specifically this column of this data frame. All right. This may seem quite simple, but once you're debugging or you've asked ChatGPT to write code for you, one of the most common kind of errors that ChatGPT makes is not grabbing the right data in the first place, right? So that's why I'm sort of pausing on this step. You should do the check yourself of what sort of columns or data frames should it be referring to make sure that it's getting that right. Okay. All right, so we found our data frame, we found that specific column. Awesome. What is that first piece of information we need? In this case, this is a pretty straightforward question. We already know it's just that titles column, which is awesome. And then is there an existing function that can help you get to your desired output? All right, this is a great moment to sort of use ChatGPT or Google or whatever to grab a function that'll help you do this. I'm going to walk through an example of how this will look. But this is sort of a common workflow you might want to go through if you're writing a little bit of Python yourself. Okay. All right, so that very first bit of information that we need is our ratings data title column. So first thing I would do is just make sure I'm selecting that column specifically. This is that same column selection that we did before. So my name of my data frame, my square brackets, my single quotes, and then the name of that column inside those single quotes spelled exactly how it's spelled in my data table. All right, so this is just me printing out this column, very straightforward. But again, this is sort of my very first step to how I answer this question. Okay. Then I did a little bit of Googling. How do you find the most common word in a chunk of text? So I Googled around or ChatGPT around or whatever, and you might find a little chunk of code like this. Okay. So I want to kind of deconstruct what this is doing. Anytime you see these keywords from or import, Hex or any other code editor will usually sort of highlight them as keywords for you. So you got a little kind of visual hint that these are sort of keywords to know. Import from or from import can show up in either order. These are going to be telling you that you're bringing in a function from a library. Okay. So in this case, we're importing a function called counter from a library called collections. Okay. So again, I'm not going to get too far into the weeds on this, just to start getting you familiar with how this will work. We're bringing in a function that already exists. Somebody else has already written a function that seems like it does what we want it to do. Okay. So we can bring in any library using our from keyword and import anything specific that we like. All right, so in this case, I've typed in from collections, import counter. I can even run that cell to just make sure I don't get any errors, and I haven't. All right, so this is me importing a function from the library. Okay, and then the second, so we've sort of done this line, we'll sort of talk a little bit more about that later. But the second line here looks actually quite familiar to what we did before. All right, so we know what this ratings data title is. This is just referring to my specific column. And then down here at the end, we see this dot and then a method name and then some parentheses, right? This is very similar to our dot size or dot mean, right? So this is operating on this chunk of data and it's called most common. So I can sort of assume that it's going to try to find the most common word. All right, so I can kind of get a little bit of a sense for what this is doing, even though we've only been talking about Python for 1 hour. All right, you can kind of get a sense of what's going on here just from sort of the words and the labeling. Okay, so let's take this for a spin. We are going to do our new function. I'm going to just copy paste my title name right on in here to save myself the typing. You should feel free to copy paste as much as you want when anytime you're writing Python or an Excel formula or anything else for that matter. Just saves you from some typos. All right. And then I'm going to apply my method that I found, this most common. All right. So once I run my cell, let's see what I get. Okay. So it looks like what I'm getting here is not exactly the output that I wanted, right? The output that I wanted is a list of words in order of most common to least common. It seems like what's happened here is I've got good news, bad news, one, the stakeout, one, the robbery, one. It actually looks like what this is doing, if I scroll back up to where I was just looking at my source data, is it's not counting the words, it's counting each whole title as sort of a thing to count. And it's saying that there's one episode or the one instance of good news, bad news, one instance of the stakeout. Really what I want it to do, right, is be adding the words the together, or the word news appears twice. So I'd want news counted for two, right? That's the sort of counting that I want. So this is sort of getting to part of what I want, but not all of what I want. Okay. So this is the sort of iteration that you're going to need to do as you're kind of figuring out what function to use for things. Okay. So we're going to need to figure out how to split up our words, right? This is currently treating each of our title, sort of that whole string, as a entire word. And we want it to actually split up each word. So anytime there's a space, we want to kind of like good counts, news counts, bad counts, news counts, right? That's what we want to do here. So this is a great example of a time when we want to do a little bit more manipulation of our text. Okay. So we are going to do some other functions on our title data. Okay, so our titles are obviously strings, right? They're not numbers. So the functions we were doing before, we were multiplying, adding together, right? We're not going to do that, but we're going to apply some other methods to our title data. I'm going to put this up here. You can also, once you've gotten sort of a long result, you can sort of collapse it here if you don't want to have to scroll. Okay. All right, so we are going to use a couple of other methods here. All right, so I'm going to pull out my title data again. We're going to use some string methods. All right, so these are some new functions we have not seen yet. First one I am going to use is, just pop these all together. We're going to use a string function called split. All right, what split is going to do is split on any white space. All right, so I'm going to use .str for string .split, which is going to split on the white space. Okay. I'm going to add a couple other pieces onto the end. All right. And we'll get this result. Okay. So what I've done here is I've taken my title column, I've applied this function .split, I've applied this function .explode, and I've applied one more function, reset index. Okay, so I've applied three functions, three methods, if you will. And what is all of this doing? Most easy to demonstrate here in our little kind of preview of our results. So first thing to notice is that we have 421 rows in our little preview of this, sort of the results of this little chunk of code. When we started with our ratings data, which has 172 rows, right? So we've expanded, we've gotten bigger over here. And you'll see our, in each row of this little preview, we have good as one word, news as one word, bad as one word, etc. Right? So we've split out our text into a variety of, into each sort of word being on its own row. All right. I can save all of this to a variable as I did before. I might call this something like title words. So I'm saving all of this info to its own data frame. Once you do that, you'll see it appear in your data browser on the left-hand side, and you'll see index, which is our kind of a row number, and then title, which is that individual word. Okay. All right. So what we're gonna do now is we're gonna try our function again, right? So our function that we used here, counter earlier, didn't quite work, right? Because our text wasn't separated out the way it needed to be. We're gonna use this function again, but instead of just giving it our title, we're gonna give it these words that are separated out that we just did in the previous step, okay? So what exactly am I gonna give it? Let me do another Python cell here. I want to specifically give it just that second column of our result from earlier, right? I want to give, let's see, did I collapse it? Oh no, I just put it in my variable. So title words, print that out again. Has two columns, right? It has its index, it has our title, or a column labeled title. It is just individual words. I only want that second column. So same thing here, even though I just sort of created this data frame right up here, I can treat it like a regular old data frame next time I reference it. And I can do my square brackets, my single quotes, and my column name right here. All right, so in this case, I can run that and it's gonna give me this nice little list. This is a little preview, so I can see that it's just getting each word individually as an array, as a list of those words. So I'm going to run my function again. So I'm going to copy all of this. Highly recommend copy pasting to help avoid typos. All right. But I'm going to get rid of my specific reference to my original data frame, and I'm going to replace that with my title words. All right. So what I'm working towards here is getting that same result, but for the individual words of my episode titles and not the full title. Okay, so this is looking a lot better. All right, so the word the is appearing 169 times in those titles. The word Jerry is appearing 3 times. That makes sense since he's the main character of the show. And then we see a bunch of other words appearing multiple times. Good appears multiple times, shower, Chinese, parking, etc. All right. So we don't know everything about each individual function that we just talked about, right? We didn't cover each individual method and function in depth. All right, but it's not too many steps to get from just our original data, which is here. We've done sort of 2 steps. First step is just sort of splitting up our words. And then second step is applying this function, which is doing the handy dandy sort of counting, summarizing for us. Okay, so quite powerful. It would be sort of quite a pain to do this same thing in Excel. You need to sort of split the titles out into all the columns. You need to combine them all into a single column. You need to do a pivot table to summarize, right? This would be several steps. Python can do it in fewer steps and on a bigger data set, right? If you have a really big data set, this would be faster than doing it in Excel. Okay. Any questions about how we got from our original column to this result? All right. Cool. All right, so this is sort of the piece we just ran through. The function names, the sort of specific like function, the string thing where it's dot split, dot explode, etc. Those are all things that you can find from, again, that's a great like part in your process to use your AI assistant, right? Google, whatever, to grab your function names. But what's really important is that you know that you need the words from the specific column in the specific data set. A very common error that ChatGPT and others will make is they'll show you the correct sort of code for what you need to do, but they'll make up a fictional title name or a fictional column name. And if you're not looking closely enough, you're not like deep in your own data set enough, that's sort of a hard error to catch. It'll give you an error message and you might not really see why. Okay? This is why this sort of data browser, understanding the context of your data, looking at those first few rows yourself before you start is super, super important. Always been important, but I would say is even more important with these tools. Okay. So we just talked through this. All right, so next thing we want to look at is sort of what is the power of using a function. It's this idea that we can sort of repeat that same set of steps on a different piece of data. So if you look in your data browser at your athletes data, I'm just going to collapse this for a second because it's taking up a lot of space. I'm going to have you all take a stab at this with our athletes data. So since we're about to work with a new data frame, I'm going to look at my first few rows, right? Very important. Athletes data dot head will show me my first few rows. So specifically, the next question we're going to answer is what are the most common words in these athletes' philosophy statements? What is an athlete philosophy statement, you might ask? I was asking the same thing when I found this Olympics data. If I look at the first few rows of my data, I scroll to the right over to my philosophy column. A lot of athletes have submitted some sort of quote or mantra that seems to like, I don't know, that they follow as an athlete. I think it's really funny that this is in this like international data set, but it's here. I want to know like what inspires these athletes. What are some of the most common words that show up there? So your task, this sort of next activity that you're going to take on is you're going to sort of use this same methodology that we just followed to figure out the most common words in those episode titles. But I want you to figure out the most common words in our athlete philosophies. Okay. So I will leave up what we just did on the screen for our episode titles. And your task is to do this for our athlete philosophy data. Okay, so your result should be something that looks like our actual result, sorry, which is here. Something that looks like this, but with the results from that philosophy column of our athletes data set. All right, so this down. This all on the screen. Okay. I'll leave this up as a hint. I'm gonna give you all a couple minutes. Give me a little wave if you're stuck. Back. All right, did anyone get sort of our most common words from philosophy statements? Yes? You want to tell us what you wrote?
Word counter,
Right.
explain counter, counter brackets, athletes under square brackets, quotes, philosophy, and dot most common.
All right, great. Okay. Sorry, from collections import counter, tell me your second line again. Sorry, tell me your second line one more time.
Counter, athletes underscore,
All right.
square brackets, philosophy,
Okay.
most common, dot most under common, and rounded brackets.
All right, cool. Okay, let's give this a whirl. Okay, so result we get from this, first thing is NaN, that's sort of like a code for empty or none. All right, so it looks like a lot of athletes did not submit this info. It's all good. Never give up. It looks like 11 of them submitted never give up, which is pretty funny. Speed is the answer. 3 of them trust the process. 2 of them. All right, so a lot of them submitted the same one, but when we get about down here to wrestling is my life. That's only goes to one person. All right, and from here on out, they're all sort of individual quotes or individual sort of unique answers to this question. So this is pretty good. The only thing we've missed here is what we've done is kind of similar to our first pass, getting our episode words together, or our title words together, I should say. So this is sort of doing the same thing as our good news, bad news shows up once. The other line that we want to add in here is the step that we did to separate out our words. All right, so here in our previous example with our episode titles, we also did the step to split out our individual words from those strings. So we're going to go ahead and do that here as well. All right, so I'm going to add one more line to what you just brought us. I'm going to bring that into here. In this case, I'm just going to put it in the same cell right up above. And I'm going to do a couple of changes. All right, so this is the same line that we used before, but I want to sub out the column that I'm using here. In this case, it's my philosophy column. I'm going to sub that for my ratings data title column right up here. And then I'm going to give my variable name something that makes a little more sense for this. Maybe I'll call it philosophy words. It's called philosophy, something like this. All right, so what I'm doing here is storing in this new variable called philosophy words. I'm storing my philosophy column that is being split into the individual words that make up that column. All right, now that I'm doing that, I'm going to replace, so down here in the chunk of code that she gave us just before she stepped out, I'm going to replace my original data frame column with my sort of modified one here that's splitting out the words. So I'm going to take philosophy words and replace where I had my athletes data down here. All right, I'm replacing it so that I'm going to get a result from those individual words instead. So I can double check over here in my data frame or my data browser in my data frame list that I have a philosophy words data frame being generated and stored. It's got 66,000 rows, which makes sense. There'd be a lot of different unique words in these statements. All right, and then in my results here, once I run my most common thing, I can see all of my words and their individual counts. So a lot of these words make sense. To, the, and, you, is, etc. Right? Those words are showing up a lot, but as I scroll down a little bit, I see words that make sense, right? Athlete is showing up, work, always, you know, best, right? Because they're just see words in here that kind of make sense for an athlete statement, all right? So this is the power of the function, right? All I've done here is I've taken these two sort of same lines of code that we've used before, and I just made a few substitutions. I substituted in the column name that we're referring to in our original data set. I changed my variable name just to like make more contextual sense. And then I swapped that variable name and column name into my counter input to get this output. All right. So the moral of the story is that once I know how to achieve this for one data set, one array, one data frame, I can achieve it for any data frame now, right? You could go and do this for the athlete description column, the episode description column, the transcript column, right? You could do this for any chunk of data just by making those same substitutions that we just made. All right, any questions about how we got to our words from our philosophy statements? Anyone getting any errors? Feeling okay? Okay, cool. All right. Great. We're gonna back up now a little bit and talk about what exactly that library, that function is doing. So anytime you're using a function from a library, you're gonna need this keyword import that we talked about briefly before. You only need to do this import once. All right, so you may have noticed here, I copied this line, this from collections import counter. I actually only need this line once in my project, and then I can use counter anywhere else below. I don't need to rewrite this line anytime I'm going to use it. I'm going to comment it out. That means I'm going to put a pound sign, hashtag sign in front of that line. And now this is a line, it's going to turn gray. Python's not going to execute, or Hex is not going to execute that line when it runs now. Okay, so you'll see little like comments scattered throughout. And then I can uncomment and you'll see it kind of highlights again. This time it will run. All right, so I don't necessarily need that line again. As long as I've imported a function once, I can use it as many times as I want. Okay. All right. So just to kind of deconstruct what exactly we're doing with our counter and our most common sort of thing that we've imported. All right, so some functions are going to give you an object which has functions of its own. All right, and those functions are called methods. Okay, I don't want to get like too deep into the specifics of this, but I do want to explain why we have counter here with our round brackets, and then we have most common is dot most common with nothing inside the brackets. All right, so this is, in this case, counter is our object. And this is our method that we're doing on that count. All right. You can always check the type of something if you're not sure. Is it an object? Is it a data frame? Like, I'm not sure what this is. You can always put it inside of this handy dandy utility function called type. All right, you can put anything inside of a type and sort of ask Hex to tell you, ask Python to tell you what it is. Okay, so let me show you what that looks like. I'm going to collapse our little thing here. So if I asked it, for example, what is the type of ratings data? It's going to tell me it's a data frame. All right, that makes sense. We've already been talking about data frames in this class. I could also give it other things that we've talked about. I could give it a little list. Let's say, what's correct here? I could give it a list or a piece of text and ask it to say, hey, what type of thing is this? In this case, it's just going to tell me very simply, this thing is a list. This thing contained in square brackets is a list. All right. If I take out the list and just give it an individual piece of text, it'll tell me that that is a string, str for short. Okay, so type is going to be a thing that tells me what is inside. So I can take the type, for example, of this counter thing if I wanted to, and this is going to tell me that a counter is of type counter. That's not a very helpful answer, but whenever it tells me that, that's a signal that this is an object. The only reason you need to know it's an object is that any object is going to have methods, aka more functions that you can do to it. All right, so counter is basically an object. It's essentially like a modified data frame. that has a bunch of these sort of built-in types of functions that you might want, like most common. Okay. All right, so this is sort of an updated version of the example that we just walked through. This is maybe a little closer to how we might write it as a function. Okay, so our first two lines were the same first thing we tried before, right, where we get each title, good news, bad news counts as one, the stakeout counts as one, etc. What I've done here is sort of the same concept of what we did with that line, that are like dot string, dot explode, that line. But we've sort of spelled it out in sort of another way in Python to do the same thing, to accomplish the same thing. So I'm going to kind of talk through this code. We don't know exactly what this code does yet, but I want you all to get a little bit comfortable sort of looking at this sort of code and kind of understanding, beginning to be able to decode what it means. Okay, so we're going to do that together. So all words equals empty square brackets. We don't know what this line is yet, but we've talked about these components. So anytime we have a label like this on the left side of an equal sign, that's a variable. We're assigning something to a variable. All right, so all words is a variable. And square brackets, the main place we've seen square brackets before is lists, right? So this is saying we're going to put an empty list, like a placeholder empty list, in this variable called all words. Okay. Then we're going to do a little looping action. All right, we haven't talked about loops yet. So this is new. We haven't talked about this, but let's sort of talk about the concept of what's going on here. For title in the title column of our ratings data set. All right, so we know that list contains 172 titles. For each one of those titles, for each word in those titles, so we know our dot split was separating our words on the white space, right? So for each of those titles, for each of the words in those titles, all words dot append. We know that when there's a dot method like this, it's doing a function on this thing. So dot append the word to all words. All right, so what does append mean? It means add on to, right? So just from starting to look at this, we can see, okay, for each title, for each word in that title, add that word onto are all words. What is all words? It's our empty list. So what this is doing is it's going to take a title, let's say good news, bad news. It's going to say for each word in that title, let's say good. It's going to add that word to our all words list. Okay. For the next word news, it's going to add that word to our all words list. For bad, it's going to add that to our list. For news, it's going to add that to our list. And it's going to go to the next title. All right, it's going to do that all the way down and give me a nice, really long list of all my words. Okay. That is essentially what our kind of what we did in our kind of dot string, dot explode line, a little bit more spelled out here. It's like looks a little more complicated, but maybe is a little bit more easy to kind of walk through. All right, we've got that list of all of our words, and that's what we're going to run our dot most common method on. All right, so we're going to give our counter object all of those words and ask it to run its most common method. Right? So there's a lot going on here. The purpose of this is not that you sort of like memorize how to use counter or what all the methods are or any of that, but to start to recognize some of the patterns that come up. All right, import means there's a library function. Equal sign means you're saving some stuff to a variable. All right, we know what accessing an individual column or row looks like, so you can sort of pick that out of the text, right? So what we'll do a little bit more next week, we'll kind of get into some more examples like this. But a lot of what you need to know in order to use a little bit of Python is to be able to get Google or ChatGPT to sort of spit you out the chunk of code that you want. And then you need to be able to see for yourself, I just need to switch in the actual column that I want from my data set, not the column that it's just referring to from the example. Does that make sense? So switching out that we did before, you can make that same switch here. We could do athletes data brackets philosophy. And the same code would give us our same results that we just did, that same swap we just made here. Make sense? All right, cool. Okay, so the last little bit that I want to show you is kind of a preview of next week. We're going to talk about kind of why you might use Python for this sort of analysis. So far, everything we've done would be quite easy, maybe like medium easy to do in SQL, and maybe a little bit of a pain, but possible to do in Excel, right? This is all stuff we can do another way. You probably know one or both of those tools better than you know Python. So if you were like doing this yourself at your job or for a class, you'd probably use one of those tools, right? So let's talk about an example where we can actually use some of the power of Python. Let's say we wanted to make a word cloud of all of these pieces of data. So word cloud meaning from our data set, the more often the word appears, the bigger the text is in our result. And we want to generate an image, we want colors, we want it to be all arranged. How might we do that? So I typed into ChatGPT, how do you make a word cloud out of Python, right? And I got a chunk of code. All I need to do if I'm sitting here with a little bit of Python knowledge, I need to be able to find that chunk of code, and I need to know what I need to plug in from my data to make it work. So we're going to talk through this example, and we'll get into more examples like this next week. All right. So I am going to bring in this chunk of Python, which I got from Googling how to make a word cloud out of Python. All right, and I've got this little chunk so far from word cloud, import word cloud. I don't need to know exactly what that is, but I know since I'm importing something, that's a function, right? I'm importing something from a library. I'm importing another thing called matplotlib. That's another name you'll recognize if you do this very often. That's a visualization library. It's got a lot of handy functions for this. All right, and then in here, I've got a couple of things going on. So I've got something on the left side of an equal sign. I've labeled this Rachel's word cloud, all right, but we could label it whatever variable name we want here. So I'm saving something to a variable. On the right-hand side of this, I've got word cloud. That's the same thing I've imported. So I know that's probably, and it's sort of at the front of my line. So it's probably an object, right? I'm going to give this object a bunch of pieces of information. I'm going to give it a width, a height, a background color. All right. And then scroll a little bit over. Didn't split super cleanly onto this line. Maybe I'm going to close my data browser so we can see it all in one. It's going to do a dot generate. So I know that that's something, I don't know what that is, but it comes from more word cloud, right? So I can sort of assume it's coming from there. Generate is going to do this space dot join, and then in here it's going to refer to a specific column in a data frame. All right. So and then down here we've got PLT dot some stuff. So these are some methods. I can see my PLT is here. I don't totally know what all of this is doing. And the point is you don't necessarily need to. All right, what you need to know is recognize where it's referring to a specific column and what data might you want to plug in there. All right, in this case, I want to plug in my philosophy words, my athlete words that we've pulled out of the athlete philosophy statements. So I'm going to take our philosophy words reference and I'm going to replace that here. This, paste, there we go. All right, so I'm pasting in my reference to all of my philosophy words. All right, so hopefully I copy pasted that correctly. Let's take this for a whirl. All right, of course I haven't copy pasted something correctly. Let's see what it is. All right, let's see, start, copy paste fresh. Deleted something. Okay, great. So I know it works here when I run it with my title words. So I probably typoed my philosophy. All right, but this is generating a word cloud As you can see, I've set my width and height to be the same, so it's generating it as a square. I've set my background color, so it's doing that, and then it's doing some sort of automatic, blue, green color scheme, etc. So this would be, as far as I know, there's not a straightforward way to generate this out of Excel or SQL, right? This is a very customizable visualization. I can set other colors, I can make it bigger, I can plug in other data, right? Like I can do a bunch of things with this. And I can do this over and over again, right? Let's say I have 100 different TV shows and I want to generate a word cloud for each of them. I could set this up, give it a list of my 100 different data sets and have it run through all of those. And it's going to generate all these for me, right? So this is without this. Otherwise, you'd be like pasting one into wordcloudgenerator.net or whatever, downloading the file, pasting the next one in, right? Like that's how you would do this otherwise. So this is maybe kind of a silly example. You might not need to generate a lot of word clouds in your day-to-day life, but this is to give you a sense that any sort of visualization, analysis, out off the wall visual thing you want to do, you can do it in Python. And with knowing like a little bit about how things are structured, how to access your data, between that and sort of Googling or getting an AI sort of outline of what the chunk of code needs to be, it's not too hard to put those two pieces together and get a cool result like this. This is what I was talking about at the beginning of class, where knowing just a little bit of Python is many, many steps beyond knowing none. All right, even just knowing that you can achieve stuff like this and that with sort of enough Googling you could get there is pretty cool. All right, so we'll get much more into kind of these sorts of functions and how all that works next week. We've covered a lot of stuff today. So yeah, that's what we've got. So I just want to make a couple other notes sort of about your toolkit, right? If you've been here the last couple of weeks and you've learned a little bit of SQL, you might be thinking, okay, the first chunk of this session was pretty similar. The first few bits of Python we did were pretty similar to everything we did in SQL. In general, with analytics or really with anything, I would encourage you to start with whatever the simplest tool is that gets the job done. All right, so if you can do something in Excel, if you're at your job, whatever your internship, trying to figure something out, like see if you can get what you want out of Excel. Often you can, you're good to go. Once you start working with those larger data sets, you're doing a lot of manipulation, you're sort of doing the same analysis over and over. That's a great point to sort of graduate to SQL, right? You can sort of save those queries, use them over and over. It's going to save you time over Google Sheets. And then once you get to that step where you're trying to do something a little bit more complicated or a little bit more customized than what you can accomplish in SQL, that's a good time to try it in Python. All right, so think of this as something in your toolkit that you might not use in every single use case, but you kind of know that it's there for this next level. That said, when you're learning, right, it's in Hex, it's very easy to switch back and forth. So you can try both. We'll see that in our last week. You can run SQL, run Python, run SQL again. I do that sort of thing all the time. So we'll talk more about like kind of how to do that, but that's kind of how to think about where this fits in. Okay. All right, so I know that's kind of a lot of information for this first one. First week talking about Python specifically. Next week is going to be our second week focusing all on Python. All right, we're going to get more into functions, what you can do with functions, defining your own functions. And then on our last week, right before Thanksgiving, we're going to do our kind of put everything together, create a little portfolio project with the SQL and Python stuff. Last thing I wanted to say about this, there's a lot of Python tutorials and stuff online. Python's been around forever. A lot of those tutorials, if you're looking to kind of continue learning on your own, will start with a bunch of steps about how you have to download and install all this stuff. With Hex, you can just kind of skip all of that and just start with the Python commands. Hex has kind of already done the like environment setup for you. That's why I like to use it to teach this class. And for anyone who's kind of a beginner, you can skip all the like installing stuff to your computer that can get a little hairy if you're new to it. And just start with Hex. You can create your own new projects. In here, you can upload your own data sets to the files and interact with them as data frames. So hopefully that's a handy learning tool for you. There's a feedback form from the Digital Lounge. Please fill it out if you found this session helpful. And yeah, otherwise, please come back next week for part 2, and then a week after that for our final kind of portfolio day. I'll hang out for a few more minutes. If you have questions, error messages, or anything else, happy to chat. Thanks, everybody.